So for question 113, we have this function, and the key thing to notice here is that the x squared is being multiplied by this parentheses quantity. And so we have not talked about how to deal with multiplication of factors, so what we need here is we need terms. So we need everything to be separated by an addition or a subtraction sign, and then we can differentiate term by term. So we want, again, to remove the parentheses to first simplify, and so to do that, we will distribute the x squared to both of these terms. So our function, this is not our derivative, this is just FOILing, distributing in this particular case, distributing the parentheses out. We have x squared times 2 over x squared plus x squared times 5 over x cubed. All right, so now we simplify, and just to make it very clear, you have two terms, this x squared, those cancel, so you get 2 plus, here you have x squared over x cubed, so this x squared over x cubed, you can subtract the exponents, you'll end up with an x in the denominator. And another way of thinking about this is you have 2x's over 3x's, so those 2x's cancel, and you have an x in the denominator. Now, of course, that x in the denominator still has a 5 in the numerator. Now, after you do all of that work, it kind of feels like you should be done, but you're not, because you haven't actually applied our derivative rules. So after you simplify, in this case we distributed, then our second step is we actually take the derivative. All right, and that is where we use our rules that we talked about in class. All right, so when we take our derivative, our f becomes f prime of x. The 2 is a standalone, all by its little lonesome there, constant, so it becomes 0, plus, and then this 5 over x, that's not in the right form. Now, why is that not in the right form? Because for 5 over x, we need the x in the numerator. So before we differentiate this, we rewrite it so that this x pops up into the numerator. And in order for that x to pop up into the numerator, we would keep the 5 and then make the exponent a negative. So we're really trying to differentiate 5x to the negative 1. So differentiating 5x to the negative 1, we bring the negative 1 down. So that becomes 5 times negative 1, or negative 5, x, and then minus 1, we get negative 2. All right, so the 0 here is just to emphasize that this 2 standalone constant became a 0. Obviously, we do not have to write that. So this becomes minus 5x to the negative 2. And that would be a perfectly appropriate way to notate the answer. Of course, you can also bring this negative exponent with its base, so the base plus the exponent, you could bring that down into the denominator. Notice that this negative 5 has a positive 1 understood exponent, so that is not going to move because the operation between negative 5 and this x to the negative 2 is multiplication, so the negative 5 stays, and it's just the base plus the exponent that moves down into the denominator. So either of those are perfectly acceptable formats for your derivative.